your graphing calculator and let's try to find the zeros of this function graphically. So here's my function, and now when I hit graph, there comes our parabola, but oops, it doesn't hit the x-axis, so it doesn't have any zeros. It doesn't have any real zeros. However, we can solve this algebraically and find out that there are imaginary roots or imaginary zeros. Now, since the roots are imaginary numbers, we won't be able to solve this equation by factoring. We're going to have to use another method. Another method that we can use is the quadratic formula. Hopefully you remember the quadratic formula back from Algebra 1. In case you don't, there's the song, the Pop Goes the Weasel song, that can help you remember it. So in your notes, make sure you record this. The quadratic formula goes x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So notice the right side of this formula is all about a, b's, and c's. Where do we get those a, b's, and c's from? We get them out of our quadratic equation we are trying to solve. Any equation that's set up in standard form looks like this. And so essentially the a, b's, and c's are the coefficients in front. The a is the coefficient in front of the x squared, the b is the coefficient in front of the x, and then the c is the constant number at the end. So in this particular quadratic equation, a would be 1, b would be negative 6, and c is positive 12. And I'm going to leave the x's out there. So now all I'm using is 1, negative 6, and 12, and substituting them into the quadratic formula. So negative b, that'll be negative 6, which is really going to be positive 6, plus or minus the square root of negative 6 squared minus 4 times a, which is 1, times c, which is 12, all over 2 times a, or 2 times 1. Once we have our values substituted in there, now we're just going to simplify this. So my first number is a 6, plus or minus. Now I've got a whole bunch of numbers underneath that radical, which we need to do those operations on. And in the denominator, 2 times 1 is just 2. So underneath that radical sign, I'm just going to use my calculator to simplify that. I just type it in, negative 6 squared minus 4 times 1 times 12. And I get negative 12. Now notice, this is why we're getting an imaginary answer, imaginary zeros, because of this negative sign right here. So when we've got a radical negative, we need to pound out the negative and brand him with the I for imaginary. And now this radical 12, I believe, could be simplified, because radical 12 is not safe walking the land of Scroot. Radical 12 will be attacked by radical 4 and radical 3. And then we should all know that the square root of 4 is 2, so I'm just going to simplify that. And now notice, this is our unsimplified answer here. We can still take this a little bit further. Both parts of this numerator are divisible by the 2 that's in the denominator. So I'm going to simplify this. 6 divided by 2 is 3, plus or minus 2i radical 3 divided by 2 is going to be 1i radical 3. So the two zeros of this parabola would be 3 plus I radical 3 and 3 minus I radical 3. Let's look at this function. Here's the graph of this function. And notice this has real roots. It crosses the x-axis in two different spots. But we can still use the quadratic formula to figure out those roots. So in this particular case, my a is going to be 1, my b is going to be positive 2, and my c is going to be negative 6. So into the quadratic formula we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And now again, we just need to simplify this. So I will take my calculator and simplify that b squared minus 4ac part, which is positive 28, so no negative underneath that radical, so we don't have imaginary roots, which is what the graph was showing us. It looks like we could attack that radical 28, though, and simplify this a bit. Radical 28 would be the same thing as radical 4, radical 7. And radical 4, that perfect square, is really a 2. And again, both pieces of the numerator are divisible by 2, so let's do it. Negative 2 divided by 2 is negative 1, plus or minus 2 radical 7 divided by 2 is radical 7. So our two roots are negative 1 plus radical 7 and negative 1 minus radical 7. If I wanted those as a decimal, I could just take my calculator, and there would be 1.645751311 and negative 3.645751311 would be the zeros of this function. So if we plug those numbers back into our original equation, we would get a 0 as an output. And those values of 1 point something and negative 3 point something match up with our graph there. If I wanted to know those decimal values off the graph, I can still do that by going second trace 0, or number 2, which will give me the zeros. And what I'm going to do here is I'll start with the positive 1 root. I'm going to hit enter. And that's going to give me what's called a left bound. You can see a little triangle up on the y-axis there. And now I'm going to move my blinking cursor to the right side of our 0. And now you see another triangle pointing here, pointing to the left. And now hit enter one more time. And there's the 1.647513 number. And if I wanted the other 0, I do the same thing on the other side. Go to 0, and now I'm going to move my blinking X to the left side of the 0. There we go, I'm to the left of the 0. Hit enter. Now I'm going to move down so that I'm on the right side of my 0. Hit enter, and then enter one more time, and there's the negative 3 number.